Good evening, everyone. Welcome to Unacademy. Welcome to the channel. Welcome to our session that is Learn Digital Circuits in 20 hours. This is our new initiative, and already we have completed two sessions on this, and today is the third session for this. फर्स्ट वाला सेशन पे हमने इंट्रोडक्शन डिस्कस किया जैसा डिजिटल का बेसिक्स एंड द एस्टरडे क्लास वी हैव डिस्कस्ड कॉम्बिनेशनल सर्क्यूट्स इसमें अरिथमेटिक सर्क्यूट्स तो कंप्लीट किया कल क्लास में जैसा हाफ एडर फुल एडर एंड हाफ सबट्रैक्टर फुल सबट्रैक्टर पैरेलल एडर and what we call this one carried look ahead at all these things we have discussed in the yesterday's class. Okay, अगर आप लोग कल का क्लास अटेंड नहीं किया तो भी आज का क्लास में कंटिन्यू कर सकते हैं क्योंकि कल आज का क्लास तो इंडिपेंडेंट क्लास है. आज हम सेकंड पार्ट ऑफ द कॉम्बिनेशनल सर्क्यूट शुरू करना चाहिए दैट इज व्हाट वी कॉल द स्विचिंग सर्क्यूट्स ऑफ द combinational circuits. जिसमें we will be discussing mux, demux, decoder, encoder, all these circuits. So let's start. So, एक minute. So today class is there. Tomorrow that is 14, 15, 16 आपको छुट्टी है. 16 is benefit of doubt, पॉसिबिलिटी है तो मैं क्लास लेता हूँ. फिर 17 से शुरू करके बिफोर 25th I will finish the syllabus. As I promise you, that will happen for sure. Okay, let's start. So let's start. Okay. So अभी तो अनअकैडमी में ऑफर चल रहा है. आज इसका लास्ट डे है. आप अनअकैडमी में सब्सक्रिप्शन ले लिया तो 2 महीना एक्स्ट्रा मिलेगा आपको एंड यू कैन सेव अप टू 30% on your subscription fee. So with the help of the extra month. So if you take for 1 year or 2 years, still you need not worry. Your subscription will be extended by 2 months and you can prepare up to GATE 2024 and 2025 with this offer. So if you want, you can subscribe using my code Shankar10. You get the discount and all the benefits. And these are our toppers this year from ESE examination. This is the new batch going to start on this Wednesday, that is January 18th. And this batch, I'm going to start signals and system at 7 a.m. on 18th Jan. And digital circuits is also going to start by VV Reddy sir. And Ankit Goyal sir is giving you the orientation and the strategy regarding this particular batch. So this is the batch for 2024 and 2025. Those who are aiming for 24 and 25, they can start their journey with the help of signals and systems happily. So let's start the class. So these are the things which you get by 24-25 subscription batches of Udan and Bunyad batches. इसमें आपको सारे PSUs का इंटरव्यू प्रिपरेशन कवर हो पाएगा, PYQs कवर हो पाएगा, इंडिया का टॉप एजुकेटर का क्लासेस मिलेगा, एक्सेस लाइव एज वेल एज रिकॉर्डेड, एंड ऑल्सो यू विल बी गेटिंग द नोट्स, डिजिटल नोट्स मिलेगा, लाइव एग्जाम्स हो जाएंगे, आपको PYQs वीडियो सॉल्यूशंस फ्रॉम 2011 मिलेगा. इतना सारे बेनिफिट्स है. Test series will be free for you. Daily practice problems will be getting, and daily doubt clearing classes will be there. All these features of your new batch, which is Udan and the Bunyad batch. So let's start the digital circuit combinational circuits today. So already we have done a good amount of content yesterday class. Okay, मैं तो arithmetic circuits के बारे में discuss किया, subtractor, adder, ये सभी चीज तो कल हो गया, ठीक है. So we have done good number of questions also yesterday class पे. So कैरी लुक अहेड आइटम डिस्कस किया. देन इसके बाद बाइनरी मल्टीप्लायर, 1 बिट कंपैरेटर एंड 2 बिट कंपैरेटर तक हो गई. चलो ये दोनों में के साथ जस्ट so please give a try for this question. Two questions were there. After that, I will start the multiplexer today. The new topics mux will be started, which is very important exam point of view. Every year they are giving question. So let me complete this, and one more question is there. After that, we will go for the mux part. Okay. So please try to answer this question. Hi, Avinash. Good evening, Mohan. Very good evening. So last 7 seconds, last 5 seconds. बताओ. नो आंसर. ठीक है. आई विल एक्सप्लेन. ये तो ऑलरेडी कल क्लास में डिस्कस किया ना. So firstly see here, NAND gate can be replaced by bubbled input or gate. So then bubbles cancel. You get here A bar, B bar and AB. This is A bar, B bar plus AB. This is the expression for A XNOR B. Okay. And this one is AB bar. This one is A bar, sorry, A bar B. This is nothing but X A less than B condition. This is A greater than B condition. And this one is A equal to B condition. इसका मतलब क्या? It is a comparator circuit, right? चलो, similar model. One more question. Next, give a try for this question. You can continue just after the Avinash. After this question, I start the new topic. You can happily continue. एक बार ये क्वेश्चन हो गया तो इसके बाद मैं नया टॉपिक शुरू कर रहा हूँ. आप लोग कल क्लास अटेंड किया नहीं किया कोई दिक्कत नहीं. अभी तो न्यू टॉपिक तो शुरू हो रहे हैं. केवल एक क्वेश्चन किया तो नेक्स्ट आई विल बी स्टार्टिंग द न्यू टॉपिक. So 30 seconds more, yeah. The output of a 2-bit comparator is logic 1 when the 2-bit input A greater than the 2 input B. The number of combinations for which the output is logic 1. Rajdeep ne diya option B. Okay, any other answer, guys? Any other answer? I think you people, if you have attended yesterday's class, you don't need this much amount of time also. So I can remove the time and I can say yes, 6 is the answer. When will you get A greater than B, sir? It is a sum of the midterms 4. Why 4, sir? Because 0, 1, 0, 0. Next, then 8, 9. Okay, 8 is 1, 0, 0. 9 is 1, 0, 0, 1. Okay. At 12, 13, 14. All these cases, first part is greater than second part. So how many times it is happening? 6 times in the total possible cases of 2-bit comparator. Chalo, that is what we have discussed yesterday already. So now let's start the new topic. So let's start the new topic now. Right. The new topic here is the switching circuits multiplexer. So the new topic is mux. Mux का मतलब क्या? So mux is very important circuit. जैसा कल क्लास में हमने एक सर्क्यूट को डिस्कस किया, इसका मतलब आप देख सकते हैं या दिस वाला सर्क्यूट. अगर ये सर्क्यूट में हर गेट लेके इसमें वायर वायर लेके कनेक्ट किया तो इफ यू टेक एवरी इंडिविजुअल गेट एंड टेक ए वायर एंड कनेक्ट ऑल द गेट्स, it will be very complex after connecting all these connections. And if you have committed small mistake also, it is very difficult to identify where you have committed the mistake. And also क्या होता है ना, different wires will have different propagation delays because of the different paths they are going through, and there are these kind of disadvantages. We can overcome all these disadvantages by using a circuit like mux. Sir, mux से क्या फायदा होता है sir? Mux में entire internal circuit comes in the form of IC. Externally, you need to give some inputs like ones and zero to implement given logic function of your choice. So what is the advantage here? आप केवल इनपुट में 0 और 1 दिया तो इट कैन इम्प्लीमेंट द फंक्शन ऑफ योर चॉइस. सो इंटरनल कनेक्शंस आप नहीं देना चाहिए. इट इज ऑलरेडी कम्स इन द फॉर्म ऑफ इंटीग्रेटेड आईसी. So definitely it is more advantages in terms of connections, in terms of delays, in terms of troubleshooting, all it is advantages. Another important job of the MUX is the main purpose of the MUX is it has a multiple input, single output. इसमें ज्यादा इनपुट होता है या केवल एक ही आउटपुट होता है. सो ये मल्टीपल इनपुट्स में एक इनपुट सेलेक्ट करके इसको ए आउटपुट में देती है भाई. So out of the many, it will select one and it will be giving to the output. That is the job of the MUX. So MUX contains many inputs and single output. So it contains many inputs and single output. Okay. So 2 power n inputs, one output line, and to select these 2 power n inputs, you need n selection inputs. So let's design, or let me show you what you have in the internal circuit of the MUX. For example, you see a simple example like this. इसमें क्या है sir? You have multiple systems connected to the input of the MUX. ठीक है? So इसमें are multiple telephone channels connected to the single channel telephone lines. You can take any example. इसमें ये सारे पे one at a time you want to communicate with the transfer. Transmission line तो एक ही है. So one at a time will transfer the data. At the other end, you have demux which can receive the data and transfer to the required computer. This we discuss little later. So now listen here. First, let's start with the two input mux. Two by one mux. So 2 by 1 mux में क्या होता है sir? Two inputs and one output. Generally we show it with a converging symbol many to one, but you can simply represent with a box like this. You have two inputs, one output. One selection. Okay, so now see. So your required condition ये है, when the selection input is 0, your output should be I naught. That is the input here will be transferred to the output. When the selection input is 1, the output is equal to I1. So the output expression for this circuit can be given as when SC is 0, your output expression is I naught. When SC is 1, your output is equal to I1. So I can write this expression as S bar I naught plus S into I1. So I can write it as, you can see here, you take S. Okay, so S bar I naught plus S I. Okay, when S is 0, you get I naught as the output. When S is 1, you get I1 as the output. This is what a 2 by 1 mux, how it will be working. So let me give you 4 by 1 mux also in the quickest possible time. Then we can directly move to the problems. So let me start, let me explain you 4 out of 1 mux. ओके देखो, मेरे पास 4 इनपुट है, एक और। ओके, 4 इनपुट्स 1 आउटपुट। those input names is I0, I1, I2, I3। सो अब यहाँ से देखो मेरे इनपुट्स क्या है सर, S1, S0, output is only 1। So based on the selection inputs, they can be 0, 0, 0, 1, 1, 0, 1, 1। 4 possibilities है। इसमें any one of them will be selected based on the selection inputs, any one of them will be selected in the and given in the output। Output Y will be, can be I0, I1, I2, I3। So what is the output expression if you want to show is S1 bar, S0 bar, when both are zeros, output is equivalent to I0, S1 bar, S0, I1, S1, S0 bar, I2, S1, S0 into I3. Okay, so here you can take the implementation will be like this. So take two inverters here. When both are zeros, I0 will be the output. And S1 0, but S0 is 1. Right. So see here, based on S1 S0, this is the internal. So this part जो है ना ये IC के अंदर होता है। हम अभी first वही understand what is the meaning of the mux, what is the internal circuit of the mux। अभी next इसके बाद हम क्या करते हैं, केवल ये डब्बा लेके इसमें input दिया तो you know this kind of output will come। Now we do all the magics required, that is हमको कोई भी circuit चाहिए तो we can implement using this circuit। It can do the switching operation based on the selection lines. It will select any one of them and giving or transferring to the output, that is for sure। Now let us see the different possible problems to be discussed on this multiplexer। Okay, let's start। Yesterday class link is available in Creatrix channel। Creatrix channel पे जाके you should go to playlist, there you can see this particular subject का playlist, there you can get all the class links। Okay, so let's continue guys। So is it clear so far? Please respond, then we can continue further। Is it clear? Okay, chalo, let's start। Let's see how to implement I told Mux can implement any logic circuit. How to implement different circuits using Mux. So for that, I'm taking two examples. Implement AND gate and NOR gate using 2 by 1 Mux। So this is the question। 2 by 1 Mux use करके हम NOR gate and AND gate को implement करना चाहिए। Okay, let's see how to make it। Suppose you want AND gate। What is 2 by 1 Mux का expression यार? आपको भी पता है 2 by 1 का एक्सप्रेशन क्या, y इक्वल टू एस बार आई नॉट प्लस एस इंटू आई वन। नाउ मेरा को क्या चाहिए, एंड गेट चाहिए। एंड गेट का मतलब क्या, ए बी। आई नीड एंड गेट। व्हाट इज एंड गेट मींस ए बी। सो हाउ टू गेट ए बी फ्रॉम दिस, वेरी सिंपल। y इक्वल टू टेक s इक्वल टू a, so y इक्वल टू a बार आई नॉट प्लस ए इंटू I1। नाउ I0 के जगह पे 0 रखो, I1 का जगह पे B रखो, हो गया काम। दिस इज I0, दिस इज I1, ठीक है। सो प्लीज अंडरस्टैंड व्हाट आई एम सेइंग, yes or no? You should take 2/1 marks. In the 2/1 marks, your I0 must be equal to 0, I1 must be equal to B. That will implement AND gate in. Okay. So AND gate के लिए इतना size marks लेना चाहिए क्या? नहीं लेना चाहिए, but I want to show you that this can implement anything of your requirement. देखो, another way is also there to do this job. Take AND gate. Make one input equal to 0, another input equal to B. Make one input equal to 1, another input equal to B. आप बताओ 0 into B क्या? What is 0 into B? 0. What is 1 into B? B. So simply, instead of writing this expression, you should understand this should be given as I0, this should be given as I1. ये I0 को देना, ये I1 को देना, then it will also do the same job. और in fact, ये आंसर और ये आंसर सेम है ना, ये I0 को दे दो, ये I1 को दे दो, बस हो गया। ठीक है, this is how you can do it. Now see here. Let's take one more example. एंड गेट तो हो गया ना। नाउ नॉर गेट, हाउ टू मेक नॉर गेट? y इक्वल टू ए बी होल बार, अरे अब y इक्वल टू a plus b whole bar, that's a bar into b bar. ओके सर, ठीक है। सो y इक्वल टू you take s bar I naught plus s into I bar, you take s equal to y equal to a bar I naught plus a into I bar. Now how to get a bar b bar? Very simple, I naught में b bar, I1 should be 0. Any time while discussion you feel any difficulty, feel free to ask me, just comment, I will reply. So that will give me I0 must be b bar and I1 must be 0. Okay sir, how to do this here? Now take 2 muxes. Why 2 muxes? Because B is available, B bar input देने के लिए आपको mux चाहिए। Here you take a 2/1 marks and एक इनपुट तो B bar होना, दूसरा इनपुट तो 0 होना चाहिए। Wait. Now how to give B bar here? How to give B bar? B bar देने के लिए क्या करना? Take a 2/1 marks. Give here B. S bar I0. So I0 must be 1. That is B bar into 1 plus S into I1. I1 make it 0. Then this will give me B bar. Okay. This will give you NOR gate. There is another method also, na, I told you. Take a NOR gate. NOR gate लेके एक इनपुट 0 करके चेक करना, एक इनपुट 1 करके दूसरा इनपुट में B देके अप्लाई करना। You should make one input 0, another input 1 and give B to the other input, then 0 plus B whole bar, 1 plus B 1 whole bar 0. So this indirectly tells what are the inputs to be given. So any method will give you same answer. So this is how we can implement any logic gate using mux. In one of the gate paper, there is a question: how many gates are required to implement AND gate? To implement AND gate, how many muxes are required? Only one mux. So see here, I will give you one table. Just a moment. if you want to make AND gate, OR gate, NOT gate, for all these basic gates, you need the number of 2 by 1 required is only 1. But for NOR gate, NAND gate, exclusive OR gate, and exclusive NOR gate, how many are required is given by 2. Okay, please understand. We have enough time. मैं तो बताया ना 20 घंटा टाइम पे 6 घंटा दिया मैंने एक कॉम्बिनेशनल सर्क्यूट्स के लिए. सो इसमें 2 घंटा कल क्लास में ले लिया और 2 घंटा आज और नेक्स्ट क्लास में 2 hours. Total we have still around 3 to 4 hours time. In that, this is sufficient to cover the entire syllabus and do very good number of questions. So I'm going in a little slow. There, based on the topic, I will increase the speed. But the time limit I kept, the 20 hours, I don't want to cross it. I will finish your syllabus in that available time only. And देखो, this is an important exam point of view. This one is important. ठीक है, चलो, let's move for the next. So here, in my example, I have taken a 2 by 1 mux and implemented the functions AND gate, OR gate, etc. If you want to implement the same gates using 4 by 1 mux, there is no difficulty at all. Just take the gate. For example, you take XOR gate. XOR gate का expression क्या? AB 0 0 0 1 1 0 1 1 पे you get all 0 1 1 0. Just how to implement this XOR gate using 4 by 1 mux is very simple. Take a 4 by 1 mux, keep S1 S0 here, and here you just copy this here. Okay, this will give you A XOR. Indirectly, when AB, here you keep AB. When AB is 0 1 and 1 0, it will give you output में 1. That is how you can implement any gate, in fact any function of 2 variable using 4 by 1 mux. Right? Chalo, let's move further. So this is the first model. Now, sometimes it is required to implement one size of mux using another size of mux. This is the next model of the questions they can ask in your multiplexer. क्या सर, एक साइज मक्स है तो मेरा पास दूसरा साइज मक्स कैसा करना चाहिए? हाउ टू मेक वन टाइप ऑफ मक्स यूजिंग अनदर टाइप ऑफ मक्स. देखो मेरा पास एक छोटी 2 by 1 मक्स है, मेरे को 4 by 1 mux चाहिए. So how to make a 4 by 1 mux using 2 by 1 mux? Let's discuss. So the question here, implementation of the higher order mux using lower order पे implement a 4 by 1 mux using 2 by 1 mux. देखो, what I have is a 2 by 1. What I need is 4 by 1. Just divide 4 with 2. You get 2. Take this 2 and divide with 2. 1. Total is how much? 3. Okay, total is how much? 3. So you require 3 2 by 1 muxes to make a 4 by 1 mux. So see here, for example, what we need to do is, this is generally 4 by 1 mux truth table. 0 0 0 1 1 0 1 1 में I0 I1 I2 I3 I am getting it. If you observe keenly, इसमें क्या S1 equal to 0, but here क्या S1 equal to 1. Okay, first part में S1 0, second part में S1 equal to 1. Okay, what I am saying, yeah, इसमें S1 equal to 0, second part में S1 equal to 1. Now listen. Just one moment, yeah. So what we need to do is we should take one 2 by 1 marks for this part. Okay. So here what I will do is S1. Here S0. S0. Okay, see here carefully. S1 and S0. Okay, when they are 0, 0, 0, 1, 1, 0, 1, 1, you need to get I0, I1, I2, I3. So here, please understand, when S naught is 0 or 1, S naught is 0 or 1, you S naught is 0 or 1, I naught I1, I2, I3 will be selected. But which I naught I1 is selected or I2 I1 is selected is decided by S1. When S1 is 0, it will select the top marks. S1 is 1, it will select the bottom marks. So in this way, you require to connect three 2 by 1 marks to make a 4 by 1 marks. Now you want to make any to any conversion. For example, see here. If you want to make 16 by 1 using 4 by 1, you divide 16 with 4, 4 will come, 4 with 4, 1 will come, total 5 multiplexes required. 256 you divide with 16, you get 16. 16 you divide with 16, you get 1, total will be 70. 256 you divide with 8, you get 32. 32 you divide with 8, you require 8 by 1, 4. 4 you divide with 8. You should not take 0.5 multiplexer 1. Total multiplexers are 37. But in this case, we also understand that 37 8 by 1 or 36 8 by 1 and 1. What is this numerators are? 4. It indicates that input contains only 4, sir. No need of 8 by 1. 4 by 1 enough for last stages. So 3 stages it will get. Okay. Here, like so, to make any marks to any marks, this is the formula we should follow. This is one of the important question in your examination. Right? Chalo. Next. Right. So let's find the solution for this question. Yeah. They have given what we call one particular circuit. You need to identify the output expression of this function. So let's try this. So when what is your F? When AB is 0, 0, that is A bar, B bar. What is the input you are getting? The C. When AB is 0, 1, what is the input you are getting? 1. A bar, B1. When AB is 1, 0, it is 0. AB is 1, 1, you are getting C bar. So the expression is A bar, B bar, C, A bar, B, AB, C bar. Okay. If you want to solve it further, you can take A bar common. A bar into B plus B bar C plus AB C bar. So like that, if you do A bar B plus B bar B plus B bar C is B plus C, na? A bar C plus A B C bar. Now you take B common. B into A bar plus AC bar. A bar plus AC bar is A bar plus C bar, na? So A bar B plus BC bar plus A bar C. After this also, you should use one more law called consensus law. C bar and product of these two is present here, that is to be neglected. But it is very difficult to solve in this way. इसके लिए मैं एक शॉर्टकट दे रहा हूँ, सिंपल सी मेथड. Okay, listen. When AB is 0, 0, 0, 1, 1, 0, 1, 1. What are your inputs? C, 1, 0, C bar. So the inputs you directly write C, 1, this is 1, 1. K map. C1, 0, C bar. Be clear. Now very simple. Fill this entire row with C value. This entire row with 1. This entire row with C bar. C bar means 1, 0. Entire row with 0. This is one pair. This is one pair. What is the expression? It is equal to BC bar plus A bar C. That's all, very simple. You don't need to work hard to write this much size expression. Simple सी बात है, with less amount of effort and time, you will be able to get the answer. Right? Got my point? So let's go for the next question. Yes. Let's do this. Okay. I am giving you time. आप लोग ट्राई करके अभी आंसर बताओ. Today actually I have some time. I have some work, but because I don't want to miss the regularity, I have taken the class. So maybe I'll leave you little early. Okay, maybe in 1 hour of time of class, I'll finish it off and I will leave. Remaining part we continue after 3 days. That is from बाकी तो हम मंडे से शुरू मंडे हाँ मंडे नहीं ट्यूसडे से we will continue. Today I will take up to 10. Okay, अभी 10 बजे तक मैं क्लास लेता हूँ. Then we take a break and the remaining we start on Tuesday. Tuesday I will finish the combinational circuits and Wednesday I will start sequential circuits. Saturday तक sequential हो जाएगा and the next week I will finish the data converters also. So next 25th definitely I will finish the syllabus. Chalo, let me check. So the here take a table. Okay. So here when AB is 0, 0, you get C, D, this one, C bar, C. Okay. So here this entire row should be, when AB is 0 0, entire row should be filled with C, D. Be careful. K map mein 1 0 will come here and 1 1 will come here. So C means 0 0 1 1. D means 0 1 1 0. CD means multiplication of these two. C bar means what? 0 bar 1 1 bar 0. Okay. So what are the midterms here is an examiner question. What are the midterms? You know, ABCD if you read 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 10, 12, 13, 15, 14. So this is equal to sum of the midterms. कहाँ पे 1 है भाई? 2 पे, 3 पे, 5, 7, 8, 9, 15. 2, 3, 5, 7, 8, 9, 15. Option D is the right answer. That's much simple question. Okay. You understand here selection lines are in the rows, then the row should be filled with the given inputs of the examiner. Whatever he give, that inputs we should take. Okay. Anybody have any doubt? Please ask me. Nahi hai to we will continue further. Okay. Next. This is the question given in GATE 2023 by electrical engineering paper only. So you people should do this question also. Please try. Okay, it is not visible properly. Okay, don't read anything. Forget to read. Wait. फिगर को छोड़ दो. ठीक है. बाकी don't read anything. Here x y z w. Okay. The order is x y z w. Okay. So I hope now it is visible. Okay. So what is the expression? Examiner is saying this is sum of the midterms 1, 3, 7, 9, 15. This is sum of the midterms 0, 1, 3, 14, 15. ओके. प्रीवियस क्वेश्चन पे आपको कुछ दिक्कत है तो अभी मैं क्लैरिफाई करेगा हाउ टू फिल द टेबल. सम ऑफ द midterms 0, 1, 3, 11, 14. So please try now. So please try. I'll do it. Now it is same as previous question. X, Y, Z, double. Earlier, Anusha, I think you asked me the doubt how to fill this table, sir. Read this. ABCD 8421 code 0000 is 0, 1, 0011 means 8421 code is 3, 2, 0100 is 4, 5, 7, 6, 8, because 1000, 9, 11, 10, 12, 13, here 14, 15, because here 10 first and next one 1. Right. Now see here. What is your input? Xy equal to 00011011. Your inputs are here. Sorry, yeah, this is not visible for you. ZW bar. ZW bar. Next, ZW 0 and Z bar plus W. Hmm. Now, you tell me what is ZW bar? 0 into 0 bar. 0 into anything is 0. 0. Z into W bar. 1 into 1 bar. 0. Z into W bar. 1. Z into W. 0. 0. 1 into 1. 1. 0. Z bar plus W. 0 bar is 1 plus 0. 1 plus 1. Z bar plus W. Z bar plus W. Next. Here 0 means entire row will be 0. Now sum of the midterms 2, 7, 12, 13, 14, 15. 2, 7. अरे यार ऑप्शंस में नहीं क्या ZW बार है ना ऐसा क्यों हुआ ये तो पॉसिबल ही नहीं है wait Z bar plus W ना this is 0 फिर भी आंसर क्यों नहीं आ रहा ओके वेरी सॉरी देखो here I have also committed mistake it is उल्टा दिया 0 1 2 3 so देखो मैं भी मिस्टेक किया okay so what is that here I naught is Z bar plus W I1 is 0 I naught ZW sorry I2 ZW I3 is ZW bar okay so Z bar plus W 0, 1, 3, 11, 14. Option D is the right answer. Okay, option D is the right answer. ये तो 2021 गेट में दिया बस. That is about this one marks का question है. So last 10 minutes of the class, let's do one more question. Okay, अभी तक एग्जामिनर ने क्या किया? He has what we call he has given a circuit. He asks you to find the function. Now suppose he do the reverse. Reverse का मतलब he has given you function. He asks you how to implement it. What are the inputs to be given to implement this function? For example, see, implement the following function using 4 by 1 mux. I am giving you the method. What is the function given by examiner? F equal to sigma m of 0, 1, 5, 7. So a bar, B bar, C bar, A bar, B bar, C, A, B bar, C, A, B, C. Do you understand what I am saying, guys? Here I have examiner has given a function. You need to draw the circuit, reverse job. So when it is 0, 0, this is I naught. So here it is A bar, B bar, C bar plus C is 1 into 1, A bar B into 0, AB bar into C, AB into C, right? So this will be I naught, this is I1, this is I2, and this is I3. Again, this is a time taking process. This is a time taking process. इसको आसान method दे रहा हूँ मैंने. That is the simple method. Let's take a table like this. It is not the K-map. Okay, take your switching selection inputs here, other input here. They can be 0, 0, 0, 1, 1, 0, 1, 1. Don't take K-map. It is not K-map. Right? If you read ABC, this represents 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now C bar and C. So ध्यान से देखो, what is, forget about this method. What are the midterms to be selected as per examiner? 0, 1, 5, 7. Very simple shortcut. Here write the answer C bar plus C. Here nothing selected. Here bottom is selected. Here also bottom is selected. So these are the inputs to be given for the 4 by 1 mux to implement your required function. Is this point clear? Very simple. This is how you can implement this function. Okay. Let's take one more example. Same way. Some of the midterms 0, 4, 6, 7. Take A, B and C. 0, 4, 6, 7. Here top one is selected C bar. Nothing selected 0. Here C bar 1. So you may require one extra inverter maximum to implement any 3 variable function. Okay, here you require one inverter and this must be 0 and this must be 1. This is how you can implement it. So sometimes examiner will ask you to do like this. Okay, so you can implement any 3 variable function. Hardly you require one inverter and the remaining is just zeros and ones, so sufficient to implement any 3 variable function using 4 by 1 mux. Okay, suppose same question, but I change. Suppose why we should take selection input as A, B, sir? Can we take A this side and BC this side, or B this side, AC this side? Yes. Chances सुनो भाई. Listen carefully. A, B, C. 1, 2, 3, 4, 5, 6, 7. How I am writing the numbers is by reading ABC. Earlier ABC order is different. Now this is different. Here ABC. A, B, C. A, B, C. A, B, C. Right. So what are the functions we are implementing here? One, zero, A, B bar, 0, 1. Sorry, B. So you take a 4 by 1 marks. Here what are the selection inputs? BC. And here the inputs are, okay. Here AC are the selection inputs. So you can give any selection inputs. Accordingly, we should change the design. Okay. When 1 minute, guys. Here I need an inverter, but here I don't need even inverter also. If I change the selection lines, it may not be possible every time, but sometimes it is possible. By changing the selection lines here, you can do it without inverter also. So कोई भी three variable function use करके कोई see here. If you have three variable 4 by 1 using 3 by variable, you should do all this stuff. But simply if you want to implement any three variable using 8 by 1, then just copy the truth table, because 8 by 1 may you have all the 8 possibilities. Just give the input. Okay, and suppose next, let's implement 4 by 1 function, or what we call 16 ABCD 4 variable function using 4 by 1. Before that, I can say one thing. If you have a 4 by 1 mux, we can implement all 2 variable functions. कोई भी 2 variable function can be implemented, and some 3 variable functions. If you have a 4 by 1 mux, extra inverter is given for you, then we can implement any 2 variable or also 3 variable function. I can write like this here. If you have 2 power n by 1 mux, you can implement n variable, some n plus 1 also. If you have 2 power n by 1 mux and also inverter, we can implement all the n variable and n plus 1 variable functions without any difficulty. Okay, if you have 2 power n mux with inverter, you can implement any n variable function and n plus 1. Suppose, sir, any big size function is given, like I have a 4 by 1 mux, but examiner asked me to implement 4 by 1 mux, but examiner asked me to implement 4 variable function like this. How to do it? Dekho. AB are my selection inputs 0, 0, 0, 1, 1, 0, 1, 1. It's not K map. Okay. So here this represents 0, CD, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now take the function given by examiner. Sum of the midterms 0, 1, 4, 5, 7, 9, 10, 12, 15. This is C bar, D bar. This is C bar D, CD bar, CD. Earlier only one variable, here 2 variables. Now what is the expression for sum of these two minterms? C bar D bar plus C bar D. You take C bar common, D bar plus D is 1 na? So C bar. Here you write this C bar D bar plus C bar D plus CD. This after minimization it is equal to C bar plus D. Actually, we have minterms and maxterms concept. Selected ones are minterms. Rest is maxterm. Now, if you have only one maxterm, directly write the maxterm expression of 10. 10 means C bar plus D. Otherwise, you add these three minterms and minimize it, you get the same answer. Now here, C bar D plus CD bar. C XOR D. Here, C bar D bar plus CD. C XOR. C bar that will tell you how to implement the functions using mux. So I am taking a break now. So आपके लिए कुछ homework देना चाहिए मैंने. Okay, take your homework. You can take a screenshot. Just and this is also homework for you. We will do it in the next class. Right? So today mux part में ज़्यादा से ज़्यादा complete तो हो गया. Few questions we will do in the next class. Demux, decoder, encoder. I'll सभी को मैं finish करेगा next class. Okay, everything I have made ready, notes, everything is ready for you. Just to the next class we will take. So next class will be on Tuesday, 17th, 8:30 p.m. Okay, I'll update. So 14, 15, 16 आप लोग भी छुट्टी ले लो, मैं भी छुट्टी लेना चाहिए, हॉलीडे पर ही. ठीक है. हैप्पी पोंगल all of you. Okay, so that is about today's class here. आपको Unacademy में सब्सक्रिप्शन लेना चाहिए तो एनी टाइम यूज माय कोड Shankar10, you get maximum discount. You want to join or you can do what we call interact with me, my classes, every update you want, then you join my Telegram channel. Its name also Shankar10, where you can get my notes and everything. So the new batch is going to start on 18th here. If you want to take the subscription as early as possible, take the subscription. Okay. So next Sunday 15th May you have AM examination. You can enroll to that. Video description where link is available. Enroll using my code Shankar10. You get a better experience because of the pan India level examination. Thank you very much for your time. Any doubts? Happy Pongal all of you. Okay. Enjoy your festival. Thank you. Bye bye. Good night.